All right, so I wanted to give you guys a second example here, just to show you, that the 5 basic steps are going to stay pretty much the same. There'll just be some slight differences depending on the type of test and the claim that you're actually looking at. So I went ahead here and walked through the first step for you. I identified the claim, which was that the mean is 3 years. That had equality, so it went to the null. And then, of course, the opposite with inequality went to the alternative. So right now I'm looking at step number 2, which is finding the rejection region. And again, before I go about finding that rejection region, I want to make sure that I know the population standard deviation, right, that value of sigma, because we know in order to use Z, we must know the population standard deviation. All right, now I know that, so I'm ready to go ahead and look at my standard normal curve. I need, again, the type of test, left, right, or two-tailed, to make sure that I shade the proper region. So remember, you look at the alternative hypothesis to get the type of test. And because the alternative contains not equal to, this is a two-tailed test. Now, two-tailed test, because the not equal to could be less than or greater than, you're going to have a rejection region that's split, half on the left side, half on the right side. Now, anytime the rejection region is split, and this is something else that we talked about last class, you are still going to use that level of significance as your area, but because the area is split between the left and the right tail, for a two-tailed test, you will always divide that by 2. Okay, so that means I'm going to be using an area of 0.05 to find my critical value. All right, again, two-tailed test is always alpha over 2. So I'm going to go to my standard normal table with an area of 0.05. And I want to get as close as I can to figure out the corresponding Z-score. Now, this is one of those special cases. All right, the two areas on either side of 0.05 are equally close. So because we can't take one or the other, we average the Z-scores, or we take the one right in between. Either way, we're going to have a Z-score of negative 1.645. All right, and again, we talked about finding these critical values last class, so if you need to, go back and look at the notes there. Okay, but that tells me this critical value will be negative 1.645, and in a two-tailed test, all you have to do is change the sign to get the other critical value. Okay, but there are always 2 critical values for the two-tailed test. All right, so again, at this point, we have walked through step 1 and step 2, and what we need to do now is calculate that value of Z that we'll use to make our decision. All right, so our formula for Z says take the sample mean. All right, so if I look back up here at my sample data, we have a sample of 25, and that sample has a mean of 3.3. So I'm going to take that 3.3 and I'm going to subtract the value of mu. Now again, mu always comes from the null hypothesis, but is essentially whatever value you are testing. We were looking at mu is equal to 3, so we're going to subtract 3 so that we can compare. And then we're going to divide that by sigma, right, that population standard deviation, which is 0.5, divided by the square root of n, and n is our sample size. So we noted right up here that the sample size was 25. All right, now again, if you want to go ahead and approximate, Just so happens this standard deviation is again going to be 0.1. And what we have in the numerator is going to be 0.3. So we're going to have a z-score calculated here at exactly 3. Now you should know your z-scores won't always come out to be exact. If you need to round them, you can always round them to 2 decimal places like we've done in the past. All right, now, just like we did last time, we're going to compare this to our shaded rejection region. All right, so in a two-tailed test, we do have to look at both the negative and the positive side. But since our calculated z-score is positive, we only really need to worry about the right side here. So if we look at that positive 3, we want to note that it is inside the shaded rejection region. All right, somewhere up here past 1.645. So remember from our last problem, anytime we are inside the shaded rejection region, that tells us that we should reject the null hypothesis. Okay, only if you calculate z and it's in that part that's not shaded, like if z had been 1.25, where it would have been in the part that's not shaded, only then do you fail to reject that null hypothesis. All right, so at this point, the only thing I have left to do is interpret my decision. And like I told you in the previous problem, anytime you're able to reject that null hypothesis, that means there is enough evidence, because that's what your test is trying to do, is reject. But in this case, notice that your null hypothesis is also your claim. So when the claim is in the null hypothesis and you reject that null hypothesis, that means that you are rejecting the claim that was being tested. Now again, you can use my flow chart here to kind of help you through until you kind of get used to how this goes, because the interpretations are pretty much the same. So notice this time my claim was in the null hypothesis. I decided to reject that null hypothesis, and so this was the interpretation. All right, there is enough evidence to reject that claim. That means basically what I'm saying is no, the mean is not 3, because based on what happened in the sample, I was able to reject that claim.